Chapter 6 is just kind of a next step of probability. All of the rules that we did for probability, all of the things you did on your quiz, you're going to do this chapter. Okay, so that's good because you've done it already. So that kind of stuff is not bad, right? There's a couple new things. There's a couple new terms. Today, there's a couple new terms. First one is random variables. Random variables. That's the first one. And then there's two types, discrete and continuous. Okay? So a little bit of review. A little bit of review. They're going to ask for probability models or probability distributions. Okay? They have two parts. Two parts to a probability model. One is the sample space, everything that could happen. Remember, sample space is everything that can happen, right? And then opposite that is the probability that's going to happen. Okay, so for example, the sample space, if I were to roll one die, regular die, just a regular die with 6 sides, right? If I was to roll one die, there's 6 things that could happen, right? They're all listed there. 1, 2, 3, 4, 5, 6, right? So those are the outcomes, right? Right below that is the probability of that happening. What's the probability I roll a die and I get a 1? 1/6, right? 2, 3, same thing like that. So this is an example of a probability model. Sometimes they're written like this. Sometimes they're written up, straight up and down. We say like this instead. It's the same thing though. It means the same thing, right? We would call these guys here random variables. They're called random variables, okay? Things that can happen. So that's what a random variable is. A random variable is a variable whose value is a numerical outcome of random phenomenon. It's just everything that can happen. Random variables are just a list of things that can happen. They're only numbers though. They can't be letters, words, okay? So that's what a random variable is. All of those guys there. So 1, 2, 3, 4, 5, and 6, those are the random variables, okay? A discrete random variable. What's the difference between discrete and continuous? Well, discrete means I can count. It's a countable number of random of possible values. When I roll a die, there's only 6 things that could happen, right? There's only 6 things that could happen. 1, 2, 3, 4, 5, and 6. That's countable. I can count those. Okay. If it's not countable, it's called continuous. It's called continuous. We'll talk about continuous later, but probably tomorrow. But random variables, like an example of one that's not discrete, that's continuous, weights, like how much people weigh, like weight of newborn babies. I could list 6 pounds, 7 pounds, 8 pounds, 9 pounds, but I guarantee you nobody here, or not guarantee you, but pretty sure no one here was exactly 7 pounds. No one here was exactly 6 pounds, right? You were 6 pounds 1 ounce, and they rounded that number, right? They rounded that number. Like I weighed 7 pounds and 9 ounces when I was born. Okay, it wasn't 7 pounds 9 ounces exactly. They rounded the 9 ounces, right? So no one's birth weight was exactly the same, right? No one's birth weight was exactly the same. So we would say, I can't list all of those, right? If I made a list of everyone's birth weight, that would be everybody, right? And if I had a list of 1,000,000 people, that would be 1,000,000 people long because no one is exactly the same weight, right? Everyone is different. So that's what continuous is. We'll talk about that, like I said, maybe tomorrow. We'll talk discrete is what we're going to focus on today. Okay, so discrete. This table just says all of the random variables are x's, x1, x2, x3, however long the list is. Right below them or right beside them go their probabilities. Okay, that's all it says. Okay. The probabilities must satisfy 2 requirements. Every probability has to be between 0 and 1. We know that from last chapter, right? Last chapter we knew that. Can't be any probabilities less than 0. Cannot be any probabilities bigger than 1, right? If I were to add up all of the probabilities, it has to equal 1. We also knew that, right? That's one of the probability rules that we talked about last chapter. Okay. So here we go. Example now. Okay. Example number 1. High school students in Michigan sometimes get snow days. Okay. In the winter, when the roads are so bad that school is canceled for the day. So instead of foggy days, they get snow days. Okay. Define a random variable, x, as the number of snow days at a certain high school in Michigan for a randomly selected school year. Suppose the table gives the probability distribution of x. So this is a list of how many snow days a high school got. Okay. So the probability that they get 1 snow day for a whole year is 0.19. The probability they get 2 snow days is 0.14. The probability they get 3 snow days is 0.10, and so on and so forth, right? So the question says, write the event, school year has 0 snow days in terms of x. Okay, so what that means is, and then find its probability. So write an event. So all of these guys here are x values, right? They're x values. They're all random variables. Can't have more than 10, can't have less than 0. Can't have, can we have something in between? Can I have like 1.5 or 2.5? Can I have those on the list? Mm-hmm. Why not? Why isn't there a 1.5 or a 3.6? Exactly. They either miss the day or they don't miss the day, right? Snow days are different. Either they don't go to school or they do come to school, right? So this is why it's a discrete random variable, right? There's no decimals. There's no decimals. It's usually going to be discrete. Okay? So write the event, school year has 0 days, and then find the probability. So what we're trying to do is we're trying to find this right here. The probability that x, because all of these guys are x, is 0. Okay, that guy right there. So we did this last chapter. In chapter 5, we did this. How did I figure out that? How do I figure out the missing part? Add up. Okay, so add them all up. So I get 0.9 plus 0.414 plus 0.10. Okay, so I keep doing that until I get all the way to here. What do I get when I add them all up? Those of you that have calculators in front of you. 0.67? Okay. So is it 0.67 supposed to go there? No. What do I have to do with 0.67? Subtract it from 1. Good. When we subtract it from 1, we get 0.33. Okay. That's the number that's missing there. It's a 33% chance that they don't have any snow days. That's the difference with snow days. They have to make them up. Can you imagine if we had to make up foggy days? Some years we'd be in school till July, right? Because we have so many foggy days. That's the difference. They get snow days, so they get days off, but then they have to make them up. So sometimes what they have to do is they don't even get a spring break because they have to make up all those days. So that's with snow days. Everyone's like, oh, why don't we get snow days? You don't want snow days because they're entire days. Foggy days is just a few hours, right? So that's why we don't have to make them up. Okay, so here we go. Getting off topic. At this high school, if more than 5 snow days are used over the course of the year, students are required to make up. Okay, so it's more than 5. Okay, so sometimes schools will like program the days in so they know that they'll have more. So if they don't use all their snow days, they can get out early, right? Like they'll be like they'll say, so if they have to go more than 5 snow days, they have to make up the time at the end of the school year. What is the probability that a randomly selected school year will require makeup days? So what we're trying to find is when do they have to make up the year? Or when do they have to start making up? When do they have to start making up days?
Get
5 or more, right? So what we're trying to do is trying to figure out the probability of more than 5. What's the probability that we're going to have to make up school days? More than 5. So we go to our table and we add up the ones that are more than 5. These guys right here, right? And what'd you get?
Won't we include 5?
More than 5 means everything above 5. Yeah, greater than or equal to, you count 5. 0.12? Okay. So you would add up everything above 5. Okay. All right. Okay, so turn it over. Example number 2. Same example. So it says high school students in Michigan sometimes get snow days in the winter when the roads are so bad that the school is canceled for the day. Define X as the number of snow days at a certain high school in Michigan for a random selected school year. Refer to the table. The table they refer to is the one right there. It says on page 363. That's in your books, but I just put it on the thing. So it's the same table. Okay. Which shows the probability of X. Make a histogram. Histogram. We haven't done that for a few chapters. So a histogram, we need a table. Already done for us. There's our table right there. Okay. So for a histogram, we use X and Y. Okay. X is the random variable. So X is the random variable. So the random variables are number of snow days. Well, our table shows from 0 to 10, right? From 0 to 10. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 9, 10. 9, 10. Okay. Those are snow days. Units are days. They're snow days. Frequency or relative frequency. Relative frequency are chances it would happen. That's probability, right? Another way of saying relative frequency is probability. Relative frequency is what are the chances it's going to happen. That's the same thing as probability. Okay, so the probabilities are going to be Y. So the probabilities, the highest probability is what? 0.33. So we need to definitely go up to 0.33. Okay, so you can label however you want. I'm just going to label by 0.1, 0.2, 0.3, 0.4. Those are the probabilities. So we'd say the probability of X. Because X are snow days, those are the probabilities. Okay? Okay, so the first bar is for 0. The first bar is for 0. That's 0.33. So I'm going to go up to 0.33. Okay. Here's a problem there. If this is 1, right? Let's say that's 1. Is that bar for 0 or for 1? But it's touching 1. They're supposed to touch. So what can we do to change that? There you go. You use the symbol, right? If we change that 1 to less than 1, it's okay to touch the line, right? Because that means 0.99999999999 forever and ever and ever, right? That's okay. We just don't want to touch 1 hole because that's the next bar. Okay, so we got to put those little marks there just to note that that bar is for 1, not for 0, not 1. Okay. Okay, so 0.19. Next one is 0.19. You don't have to label all of them, just label enough. You don't have to label each tick mark. Just label a few, they get the idea. 0.14. 0.10. 0.07. 0.05. 442. And 11. So then I need another one. Because this one goes from 10 to less than 11, right? Because I need 10 bars. Oh, wait, 11 bars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because I have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I do have 11 of these guys, so I need 11 bars. Okay. So there's my histogram. Then it says describe shape. Describe the shape. There you go. We have 3 types of shapes, right? Symmetrical, skew right, skew left. We haven't done that in a while either. So this one is skew which way? This one is definitely skew. It's skew to the, yeah, exactly. Which way would you go down the hill? Which way would you go down the hill? To the right or to the left? If you go to the left, that's like jumping off the cliff. You don't want to jump off the cliff, right? You want to go down the hill. So it's skew to the right. Okay? So we would say shape is skewed right. Skewed right means most of the data is on the low side. Most of the high bars, most of the frequency are on the low side. That's what that means. Okay. All right. So now we get more into some new stuff. Well, the vocabulary is not new, but it's kind of new. Mean. Mean. What's mean? Average, right? So sometimes they call it mean. Sometimes they call it expected value. You're going to see that term quite a bit for the rest of the year. Sometimes they'll say, what's the expected value? So if you took a test and the average was 85%, another way of saying that is if I were a student in that class, I would expect to get an 85. Did that happen for everyone? No. But it's an expected value, right? That's what that means. So expected value is another word for average or mean. Okay? So we've done means before, right? I've given you a list and you found the average. Your calculator can do it too, right? One of our stats. Now what we have to do is we have to find an average for a table. So like, give me the average of that table. Well, I can find the average of the top and I can find the average of the bottom, but how do I find the average of them both at the same time? Here we go. The formula right there. That formula is given to you. It's one of the formulas that are given to you. It's on your formula sheet right underneath the ones you used yesterday. Those two formulas, actually, the top two formulas on the right side are from chapter 5. The middle stuff is from chapter 6, and then the bottom stuff's from chapter 7. And then the back of it is next 8 through 12. Okay? So they give you that formula. But do any of those symbols make sense to you, anybody? It might, right? So you have to know how to use the formula. So the formula will be there, but you just have to know how to use the formula. And that's what I'm going to do right now. Okay? Okay, so E of X. What do you think E stands for? Not the Greek E, the actual E right there, the E in front. Expected value. Yep. This E stands for expected value, right? So E of X is the same thing as the average of all the random variables. Okay? So now let's get to the formula. Now the Greek E, sigma. Anytime you see this letter in math, doesn't matter what math class it is, what are you always going to end up doing? Adding it all up. Yep, means total. Give me a total. It means whatever numbers I'm dealing with, I need a total. Summation, it's called the summation notation because you're summing everything up, right? X. What do you think X's are? Close. The random variables. These are all the top guys. What do you think the P's are? Probabilities. They're probabilities. What we're going to do is we're going to take a random variable, multiply it by its probability. We're going to do that for each of them. Okay? So we're going to do that for this table here. This table's a lot shorter. I did this on purpose. So you don't have, if we were to do it with the problem you just did, it'd be a long, because there's 11 things to add up. This one's only got 4 things, right? Buffalo Wild Wings ran a promotion called Blazing Bonuses. I think we had this question last chapter too, in which every $25 gift card purchase also received a bonus gift card for $5, $15, $25, or $100. So if you went into Buffalo Wild Wings during this promotion and you said, I want to get a $25 gift card for somebody, not only would they give you the 25, they'd sell you that, but they'd also give you a bonus on top of that. Okay? Somehow they decided which one, random. Okay? So X is the amount of money you won on top of it. So $5, you got an extra $5 to your 25. 15, you got an extra 15. 25, 100, you got an extra. Okay? And they give you the probabilities. The probability that they would give me $5 bonus is right there. Probability 15, probability 25, probability 100. So we need to find the expected value. Expected value. We're going to use the formula. Okay? So here we go. Expected value. So the first X, what is the first X value? $5. So we're going to go $5 or just 5 times its probability. What is its probability? 0.89 plus the next X value. What is the next X value? $15 times its probability, which is 0.98. And we're going to keep doing that until we're done with the list. Then you grab your calculator, multiply, 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 and then add. And I get 637. That represents a value, so it's going to be in dollars. So that's the expected value. Okay. Now we have to interpret it. Tell what that number means. So how would we interpret that? What's an interpretation of $6.37?
Average person is getting $6.25 of a gift card.
So yeah, we're going to put in norm. We don't want to use words like expected value or not. We don't want to use words like average or mean because that can be a little confusing. We want to make it as easy as possible. Okay. So in other words, if I were to buy a gift card, I would expect to get a bonus of $6.37. Okay. So if I were to buy a gift card, I would expect to get a bonus of $6.37. That makes sense to everyone. I don't care who you are. That makes sense. Does the number make sense though? In other words, is it possible for me to go into Buffalo Wild Wings and get a bonus of $6.37? No, right? Bonuses are only $5, $15, $25, $100, right? But it's still the average. So I would expect to get something close to $5, right? Expect to get something close to $5. It's like, have you guys ever heard the average household in America has 2.2 kids? You guys ever heard that? Like the average household in America, or the average married couple, or the average couple have 2.2 kids. And you're like, how do you have 2.2 kids, right? We don't say 2.2. We say around 2. The average there's around 2 every couple who has kids. The average is around 2, right? It's the same thing, right? It doesn't make sense in context, but it's still the calculated value. Okay. And it's like the average couple has 2.2 kids and like 0.7 dogs. Like, how do you get a 0.7 dogs? Well, it's the average. So when you do averages, they don't come out nice and pretty, right? So we just kind of round them off. We say the average couple has around 2 kids and 1 dog. Some people have more than 2 dogs. Some people don't have any dogs at all, right? It's the same thing. If I were to walk in, most people would get $5. Some people would get 15. Some people would get 25. And there's a few people, 2 for every 1,000 that walk in would get $100. Okay? But that's how we interpret it. Okay? All right, last thing we'll do. Standard deviation. Standard deviation, and we'll be done for today. Standard deviation is another one we haven't heard since chapter 3, I think, chapter 2. Standard deviation. So anytime you find an average, you're always going to find a standard deviation. They go together. But here's the thing. Standard deviation goes with variance. So if you dig back in your notes enough, you'll see variance. Variance and standard deviation go together. How are they related? What's the difference between the green one and the not green one? Square root, right? So what's the relationship between variance and standard deviation? The green one's variance, the not green one is standard deviation. So how do I find one? If I have one, how do I find the other? So if I have the green one, if I have variance, I take the square root, standard deviation. What if I have standard deviation and I want to find variance? What do I do? Square it, right? Square it. Okay, here's the thing. The reason we're going through that is because if you look on your sheets, they don't give you the square root. They give you the variance formula. Okay, I don't know why they give you variance formula, but all you got to do is take the square root of it. The square root of it. Okay, so we're going to do that right now. We're going to find the standard deviation for the list we were just looking at. Okay. So I'm not going to do variance because variance, here's variance. Variance, they'll rarely ask you to calculate, but they'll always sneak it in. They'll talk about variance. They'll always sneak it into a multiple choice question. And you're like, what the heck is variance? It's the same thing as standard deviation, just squared, right? So same question. It's the exact same question. Now we have to calculate the standard deviation. Standard deviation. Okay, so standard deviation, we need a couple things. Looking at those letters, some of those letters should look familiar. Besides the Greek E. The Greek E we just saw, right? So we know we're going to have to add up. Some of these other letters should look familiar. Two of them should look really familiar because we just used them. P is probability, X is close. Random variables. There you go. Random variables, which are values. Okay. What is this guy? Mean, right? That's just the mean. So we have to take the random variable and do what? Subtract it from the mean, square it, and then multiply times the probability. So kind of like what we just did, but a little bit more. Okay, so that's what we're going to have to do. Okay, so the first one. So this is for standard deviation. First one. The mean, what was the mean of this table? 6.37, we just did that, right? Okay, so 6.37 minus, what is the first x value, or the first random variable? 5 squared times the probability, which is 0.89, good. Okay, that's the first one. The second one, what's the first value? Wait. I did that backwards. Sorry. The mean is supposed to come second. So it's supposed to be 5 minus that. Sorry. The formula was right. I was wrong. In the formula, take x minus the mean. So the mean's always going to be the same for this problem because it's always 6.37. The x value changes though. The next one's 15. 0.098. Next one, 25 minus 6.37 squared times 0.010 plus, and then the last one is 100 minus 6.37 squared times 0.002. So not only do I have to do that, but after I get that number, what do I have to do with it? And then what do I have to do with that number? Square root it. Square root it, yeah. So I have to calculate this whole number and then find the square root of it. So it's a good thing we have a calculator. Okay. Start crunching numbers. So for the first one, I got 1.670. Yeah, so you subtract, square, multiply. So for the next one, 15 minus 6.37 squared times 0.098. This one's a little bigger. 299. 25 minus 6.37 squared times 0.010. If you can, go 3 spaces past the decimal, always. It's a good habit. If you can't, go as far as you can. Times 0.002. Okay. Plus 1.67 plus 7.299 plus 3.471. Then I get the square root of 29.973. And I get 5.475. It's dollars, so probably should round it to dollars. Okay. So here we go. How do we interpret standard deviation? So what is standard deviation? If I were to give you what we've done this many times, we haven't done it in a while. The average distance or the average difference of what? From what? From the mean. Yeah. The average distance that all of the random variables are from the mean. So each one of those, on average, is about $5.48 away from the mean. Sorry. So in other words, my average was $6.37. That number will vary. The average will vary by about $5.48. All right. So $6.37 plus or minus $5.48. Okay. So on average, so is, there we go. On average, each value in the data set, each random variable is blank away from the mean. Okay? So on average, each random variable is $5.48 away from the mean. Or you could say the average is $6.37. It will vary by $5.48. Either one of them is okay. On average, each random variable is about $5.48 away from the mean. The average is $6.37. That number will vary by about $5.48 plus or minus. Right? It's a spread. It's a spread. Okay, so for this guy here, one thing. We're not going to do anything more to the notes, but I'm going to show you something. Can you imagine having to do those two things we just did for that guy there? Would it be more work or less work? Yeah, right? This has 11 random variables. How much did our last one have? 4 random variables, right? More than double the work, right? So what if I gave you this one and said find the standard deviation? You could do it. It's not hard math, right? But it's tedious, right? So what I'm going to do tomorrow is I'm going to show you how to do it using the calculator. The calculator will do it fast. Okay? All right, that's what I'm going to do tomorrow. That's what we'll do tomorrow. We'll finish this tomorrow.